Okay, this is your video on naming ionic compounds that contain transition metals, as well as identifying the ions themselves and the formulas for those ionic compounds. Now, transition metals are the elements that are located in the middle of the periodic table. They're a little valley right there. There are groups 3 through 12. So you'd have the SC or scandium group or column all the way through the zinc column, which is Zn. The reason why these metals are called transition metals is because they have the ability to have multiple charges. Now, these transition metals are not the only metals to have multiple charges. There can be some that are outside of those columns, such as tin, which is number 50, or lead, which is number 82. Those have the ability to also have multiple charges. Now, these are the main 8 examples that we'll be using in class. The first one here is cobalt. And cobalt will usually form a positive 2 charge, okay, or they'll form a positive 3 charge. Actually, let me go ahead and fix that since it's not really written like that. A 2 plus charge or a 3 plus charge. Next would be chromium, which is in the same boat, a 3 plus charge and a 2 plus charge. Now, I'm just listing 3 plus before 2 plus for chromium because it's more likely that chromium is going to have a 3 plus, but you'll be able to do either one. Okay, copper normally is 2 plus, but it can also be just 1 plus. Iron, let's see, iron mainly 3 plus and 2 plus. The mercury, which would be let's see, 2 plus and just plus. Tin, which is Sn, would be 4 plus, and I think 2 plus, yeah, 2 plus. And then lead would be 2 plus and 4 plus. And then lastly, nickel is 2 plus and 3 plus. Those are the main ions that are going to form from these particular transition metals. And what I mainly want you to get out of this is you treat the process of making your compound, like if I give you the ion, if I give you the, usually how I will identify the ion is by saying something along the lines of nickel 2. Okay, so the nickel 2 plus ion. Or I may say the chromium 3 ion. So once that's been identified, okay, and it'll be written just like this, so nickel 2 plus or chromium 3 plus, then you just do what you normally do as far as writing out your compound, whether that be with whatever anion you happen to combine it with. Now, when it comes to naming them, you have to identify which charge is being used in that particular compound. So, for example, I will show you what 2 examples of copper chloride. Okay, copper being this guy right here. All right. So looking here, copper chloride. Well, I know copper chloride is going to have a chloride ion, which is Cl minus. Now, copper can either be a Cu plus or it could be Cu2 plus. Now, if I just say copper chloride, that doesn't give you enough information. So what will happen is, if I give you the name, I'm going to give you the ion. And I'll give you the ion, the cation's identity by doing a Roman numeral. So for example, let's go ahead and do a quick combination of these just so we can see. If these 2 came together, they would form copper chloride there. And then these 2 came together, you would see this, copper chloride with 2 chlorines, because here I have 1 negative charge and this copper happens to have 2 positive charges, so I need 2 chlorides to balance it out. Now, how I identify what these different names are is based on which charge of the transition metal I used. Okay, chlorine right here will always have a -1 charge. That's never going to be coming into an account. And we identify that based on the periodic table, the worksheet I gave you, and it says IDE. Remember ID for the monoatomic ions. So if I was to name this compound right here, it would be copper, in parentheses, 1 fluoride. That 1 indicating, okay, that 1 indicating that there was a +1 charge for that copper. And then likely, or just like that one up there, I'm going to go copper 2 fluoride. Okay, and that 2 is making reference to that +2. So let's go and do a couple examples. So here I have 3 different examples, pretty much modeling what you have on your worksheet that you're going to have tomorrow in class. So first one, we have a name. Now from the name, I want to be able to get my ions. Okay, so we have name, we have ions, and we have the formula for the compound. All right, so we'll go and feel the first one, cobalt 2 oxide. Automatically, I know cobalt has a 2+ charge because the Roman numeral 2 tells me that it's a +2 charge. Okay, if it was cobalt 3, then it would have a Roman numeral 3 there. And then oxide, we should know, is a monoatomic, which means it'll be O2-. I can just put these 2 things together, right, because I have 2 positive charges here, 2 negative charges there, so I can just put these 2 together in a 1-to-1 ratio, and I get cobalt oxide. Okay? Moving on to the next one, I have the ions, and then now I want to identify the formula and the name. So you can do whichever one you want first. I'm going to go ahead and do the formula first and then go back up to the name. So automatically, I have lead, okay, with a +4 charge. 1, 2, 3, 4. And then I have nitrate with 1. Remember, it's polyatomic. So what I need to do is I need to have, okay, 4 of these nitrate ions. So 1, 2, 3, 4 to balance everything out. So when I write this out, remember my parentheses, that would be lead nitrate. Okay, 4 of the nitrates for the 1 lead. And then what I do is I know that's lead, and I know it's nitrate, but I need to identify, if I don't, from the formula and from the ions, I need to identify the name. In this case, it would be lead 4 nitrate. And lastly, we have iron oxide, which is rust. So you can go name, you can go ions. In this case, I would probably go to ions first. So we'll go oxide is oxide, doesn't matter. So just based on our first problem, we know oxide is 2- in our first worksheet. And then here's the thing. This is where your little trick is going to come into effect. All right, I have my 2 subscript here, which is going to represent the charge of my oxide, which means this right here is going to represent the charge of my iron. In this case, I'm going to have iron, and I have 3 oxides, or 3 oxygens, or 3 oxide ions, so I need 3+. Okay, so that's where your little hint actually is going to be a little more applicable instead of just making things quicker. All right, and then what do I do? Once I have my ions, I know it's an oxide, I know it's iron, and then now I have to just identify which one it is. It's iron 3 oxide. All right, so you guys will have 18 problems just like this in class tomorrow. All right, and if you guys have any questions, make sure you ask me on Friday.